This is how you do spatial temporal clustering in the R language. So, first we read our original data into R. And because in my case, the original data is in SPSS format, these are the syntax I need to use. This is SPSS file. And because of that, I need to read my foreign library first before I can read an SPSS file. So, if you haven't installed the foreign library, you will not be able to read your SPSS file. And this is how you install a new library. Go to the package menu and select install packages. Because my foreign library is already installed, so I'm going to skip this step. And once you install your foreign library, we can just copy this part of the code to R and paste it here. And we can always see how the data looks like. And this is how the data looks like. We type in the head function to see how the first 6 cases of the data looks like, just to make sure that we read in the data properly. And we don't need all the columns here. So we are going to delete unwanted column. We can just do Ctrl C and Ctrl V in here, and then we can see how the data looks like. As you can see, the columns are being deleted, and as you can see, there are some missing cases in some years for some states. If that's the case, our programs are not going to run when we do spatial temporal clustering. So we need to run this part of the code to delete states where certain years they do not have any data for police violence or police brutality. This data pertains to the number of reported cases for police brutality. So just copy this over and paste it in R. When we do this, the missing cases are deleted. And after we do all these things, as you can see, this data is in the horizontal format. We need the data in the long or vertical format, and this is what we are going to do here. The same thing, if you don't have this reshape package installed, you need to go to package, install packages, and then select reshape. And after that, run this part of the code. It's going to convert this horizontal data to vertical format. And it's always good to see how it looks like, to make sure we do things correctly. And if you see something like this, the years are in the columns, the years for different cases reported, and the state are the rows, we know we do things correctly and we can move on. And once again, to be sure, we delete the missing cases again, just to be sure, before we proceed further. And after that, we go to another step. As you can see from here, the first column pertains to the name of the state. We need to create a dissimilarity matrix And because of that, we don't need the first column here, and we are going to delete the first column. So this is what we are going to do. Copy this over, and it's always a good idea to see whether things are done correctly. So if you see something like this, this is our dissimilarity matrix. We know we did things right. Yeah. This is the head function here, where we just use. And then we can move on to actually calculate the dissimilarity matrix. And you will need these two packages to calculate the dissimilarity matrix. So if you haven't installed these two packages, go to package menu and just click install packages. And after that, just run this part of the code. And because we deleted the first column here, and this is how our matrix looks like, now we need to add the name of the states back. So just run this part of the sentence. We can just copy this over. And after that, we can move on. And we don't know what's the optimal number of clusters for the different reported cases of brutality in different states. And we need to use the elbow method to determine how many clusters we should divide our state data on. So we run this part of the syntax. Just Ctrl C and Ctrl V. Because if we right click copy, sometimes they are trying to correct spelling mistakes, and this is irrelevant for what we are doing here. So we'll see these are the within sum of squares, or total within sum of squares. And as you can see, there's a drastic decline from the first cluster to the second cluster, and from the second cluster to the third cluster, and maybe from the third cluster to the fourth cluster. And to be sure, we plot this out so that it's clearer. Copy this part of the syntax over, enter. This is what we see, and we will write there's a drastic decline in total within cluster sum of squares from the first cluster to the second cluster, and there's also a significant decline in the total within clusters sum of squares when we move from the second to the third cluster, and there's also a notable decline from the third to fourth clusters in terms of decreases in total within clusters sum of squares. So the second, third and fourth clusters may be potential candidates. And as you can see, as we move from second, third, fourth, fifth, sixth, 7, 8, 9, 10 clusters, things more or less even out. The decrease in total within clusters sum of squares, they decline. The decline is smaller and smaller as we increase the number of clusters. So this is what the elbow method gives us. The elbow method suggests 2 clusters, 3 clusters, 4 clusters, 5 clusters, or anything from 6 to 10 clusters as potential candidates to divide our state time series on. We are not sure yet. This corresponds to this, as you can see. So we use another method so that we are more sure. we use the skill hop analysis method to determine the optimal number of clusters, just like a second opinion. So let's run this part of the syntax. Control C, Control V, and the skill hop analysis tells us that the optimal number of clusters is 2 clusters. It corresponds to the elbow method. So there are some consistency between the elbow method and the skill hop method. And to be more sure, we may use a third method to determine the number of clusters we should divide our data on. Now we use the Kolinsky criterion, and this is the syntax. Just copy this over and paste it. And the Kolinsky criterion suggested 10 clusters as the optimal number of clusters for the state time series for police brutality. So if you recall from the elbow method, things even out after 10 clusters. So anything between 2 to 10 clusters can be potential candidates. And because we want to even things out, okay, I'm ahead of myself here. Let's go back a step. After we determine the optimal number of clusters, according to all these criteria, they suggested anywhere between 2 to 10 clusters. The next step would be to perform hierarchical agglomerative clustering. We copy this sentence over. Control C and Control V. And go to Windows, click on the second thing, and you see the different states with their reported police brutality. At this stage, we haven't done the cluster analysis yet. We just want to make sure how things look in terms of hierarchical agglomerative clustering. So let's go back to here, and now we are going to divide our state time series into 10 clusters. We can change the number here and try different things out. We can change it to 2. Let's change it to 2 and see, just for fun. And see how it looks. If we use 2 clusters as the optimal clusters, as you can see, only 3 states, California, Florida, and Texas, are assigned to 1 cluster, and the other states, the majority of the states, are assigned to another cluster. So things are not very even if we do it this way. So let's repeat this again. Now we have a clean slate again, no cluster assignment. And let's repeat, because Kolinsky criterion suggested 10 clusters, right? So let's try 10 clusters out. Things are more even if we have 10 clusters. If we divide the states into 10 clusters, things are more even. So we are going to go with 10 clusters. As you can see, California, Florida, and Texas, they are 1 cluster to itself. And when we decide on the number of clusters to divide our data, we can go on to this step. We merge the data back to the original data. because as you can see from here, the original data, this and this, does not have clusters membership. We just estimated the cluster membership in here, in this tab. But the original data does not have cluster membership, whether it's the horizontal data or the vertical data. This is the vertical or longitudinal data, or the data in long format, this part. And as you can see, there's no cluster membership here. So we need to merge the cluster membership back to the data in the long format so that we can do spatial temporal clustering. And this is what we do. We first run the first line of the code. And it's always good to see how things look. As you can see, now we have the cluster information for all states. That's what we need. Initially, for the data in the long format, we don't have the cluster information, right? And we just merge it. We merge the two data together, and now we have the cluster information. And because we don't need all the columns here, we don't need all these columns, we can just delete them. Sorry, I'm ahead of myself here. We may not want to delete them. We can just keep this the way it is. Okay, I'm sorry. Okay. Okay, so apparently, I'm sorry, we need the cluster information for our horizontal data. So we can just copy this. Over. Can just convert this into CSV file. Apparently, we did not like my codes here. Maybe from PowerPoint is different. So sometimes we have to retype the syntax in R. So it's being copied to the documents folder. Let's see how it looks. Okay. You will see why we need this file. And we don't need this column. We can delete this column when we open the file. And we can just close it back and save changes. And save changes and yes to everything. Okay. We also need to merge the cluster membership to the long data, because there are two ways of doing things. We can do it through the Excel file or the CSV file, and We can also do it through R in terms of spatial temporal clustering. Because of that, we need the data in two formats. Just copy this over and paste. Good idea to see how it looks. Oh, okay, sorry, typo. See, we have the cluster information, but this data is in long format. The years are top down, and because of that, the cluster membership repeats itself. So if you see something like this, you know you're doing things right. And we can go on. Now we do spatial temporal clustering using R first. Make sure you have this ggplot2 installed. If not, just go to Packages, Install Packages. Are we clear? And after that, just copy everything over. Enter. Okay, now let's see how it looks. As you can see, a different color is assigned for a different cluster. But as you can see, because there are more than 50 states in the US, it's hard to see if we do it this way. If you do all 50 states in one figure, even though their cluster memberships are distinguished by the different colors, it's still difficult to see how the trends are similar or different between different clusters. So another way would be to do it cluster by cluster. Copy this over. We first do the first cluster. Okay, see how it looks. It's clearer, right? Okay. And you can repeat your syntax for the second cluster, and the third cluster, the fourth cluster, the fifth cluster, the sixth cluster, the seventh cluster. You can just change the cluster membership here. Change it to a different cluster membership in these three places. If we don't want to do spatial temporal clustering using R, you say, this looks better, but it's not as clear as I want it to be. We can also do it in Excel. That is why we need this horizontal file. Just fire out Excel. And select out the states with cluster 1. We don't need this part. So you can just select them by copy and paste. Copy, go to a new screen, paste. What else is cluster 1? These three, these two. Just paste it over. So please paste all the states assigned to cluster 1 over to a new worksheet. so that it's easier. And paste the headers over. And now we can plot, right? We can draw a chart here, a line graph or something. We want to switch row and column, and we want the legends to be the years. And this is how it looks like. It's kind of messy. You can just move it to a new chart if you want to. So you can do it this way too. So are we clear? So we can close this file. We don't need to save the changes.